So this is a Year 9 support video looking at speed and distance time graphs. So within the Year 9 motion unit, speed and distance time graphs sit about halfway through the unit after you've looked at movements by forces and energy. In the first part of this video, we're going to look at the definition for average speed, the relationship between speed and journey time, and then we'll look at rearranging an equation. So the speed of an object tells us how far it travels in a particular time. So the number of miles covered per hour or the number of meters covered per second. Typically, if you think about a car journey, you'll talk about the number of miles covered in an hour because the number of meters covered per second in a car is not very useful given that you cover quite large distances. So how do we calculate speed? Well, we use the equation speed equals distance divided by time. That line there means divided by, so just bear that in mind. And then the units for speed depend very much on the units that you've used in the equation. If you've measured distance in meters and time in seconds, then the units will be meters per second. If you've measured distance in miles and time in hours, then it will be miles per hour. So just be careful about which units you use. Look back to the original question to see which units are in the question. When doing calculations, you get a better chance of getting the answer right and getting marks in the exams in tests if you do a number of basic things. So first of all, check what you're being asked to work out. Read the question again, probably underline the thing that you're being asked to work out or calculate or find. Those are the key words that are usually in the questions which indicate the thing they want you to get. Identify the information that you've been given, so underline any values in the question that they've already given you. They might have given you the distance in miles and the time in hours. Underline those things so you know where to find them when you come to put them into your equation. Write down your equation, and it's really useful to get into the habit of doing the FIFA, the formula, insert values, fine tune, and then write your answer. So write down the formula that you're going to use. Input your values, so if they've given you the distance, put that into your equation. If they're giving you the time, put that in as well. Use your calculator to calculate the answer and give us the answer in a decimal rather than a fraction, please. Make sure you know how to change that on your calculator if you're not sure. And then write your answer down. And once you've written the answer, make sure you write down the units. Now, if you follow those steps, you'll pick up marks for each of those steps in most cases. If you go straight for the answer and it's the correct answer, you'll get full marks for the correct answer in most cases. But if you make a mistake in your calculation, at least if you've shown us you're working out, you've got a better chance of picking up some marks. So one of the things that students find quite difficult is rearranging equations. I've already given you the speed, distance, time equation. Speed equals distance divided by time. But sometimes we need to change it. Sometimes we want to work out the distance and sometimes we want to work out the time. So we can change the quantity the equation starts with. Make it the subject of the equation. Make sure that if you want to work out distance, multiply both sides by time, and you'll get speed times time is distance. If you want to work out the time, multiply both sides by time and divide both sides by speed, and that will give you time equals distance divided by speed. You can, of course, remember both of these equations because they're relatively easy to remember. So here's a couple of questions for you to practice on. I'm not going to read through them, but what I want you to do is pause the video, make a note of the thing that you are being asked to find first, then make a note of the values you are given, then write down what you think is the appropriate equation, input your values, fine-tune your answer by perhaps rearranging the equation, and then write your answer down. So pause the video now and have a go at those. Okay, welcome back. Let's see how you did. So for the first one, you were being asked to find the distance and you were given the speed and the time. In the second one, you were being asked to find the time and were given the distance and the speed. And the final one, you were being asked to find the time as well. Now, a couple of things to point out that when you're being asked to work out the distance, you might be asked to think about how far did it travel. So the question may not say what's the distance traveled, it might just say how far. Likewise, with time, it might ask you how long it takes. And then with speed, it might ask you to work out how fast it was going for the journey. Okay, so it may not use average speed, it may say how fast is it going. So just a few things to watch out for. And again, look at the units that you've been given. If you've been given hours and miles, then use those. If you've been kilometers and hours, then use those. So that's speed. The second part of the revision for this topic is distance time graphs. We need to look at what does a distance time graph show, how we determine speed from a distance time graph, and how we draw a distance time graph. So, distance time graphs are used to show how the motion of an object changes over a period of time. So if the line is horizontal, the object's distance isn't changing. So if you've got a horizontal line, then the distance is not changing over that period of time. So for example, if this was 10 meters, it's still 10 meters, it's still 10 meters. Let's have a look at what happens if the line's slightly different. So when the line slopes up, the object's moving because the distance and the time are changing. The steeper the line, the faster the object is moving. And when the speed increases, the line gets steeper and steeper, so you'll get a curve. Okay, so we've got some examples of distance time graphs here. The red line, or the red graph, shows an increasing steady speed, so the object's moving at a steady speed rather, up to a point, and then it stays stationary. And this is always an area of confusion for students. Here, the distance is going back towards zero, so the object's returning to where it started at a steady speed. Let me give you an example. Imagine standing with your back against a wall. You walk out 10 meters from the wall, you stand still for 15 seconds, and then you walk backwards towards the wall at a steady speed. That would be a good way of describing that graph. The green line shows an object which is traveling at a steady speed, but it's much quicker than the red line. So imagine running from the wall outwards up to a point and then stopping. And then the blue line shows an object that's accelerating. So its distance is changing rapidly through this curve, meaning the object is getting faster. So this would be somebody who starts at the wall and progressively gets faster as they walk, jog, run, and sprint away from the wall. So this is a really useful graph to copy down and just make some bullet point notes around the graph about what each section means. And I would use the example of moving away from a wall to help you understand what each part of the line means. So finally then, a little kind of practice for you. Have a look at this question and see if you can work out what the correct answer is. Pause the video and I'll tell you the answer in a second. Okay, have you had a chance to think about it? So which part of the graph shows where the person is stopped? And that would be X to Y. Just for your own benefit, have a little think about what does V to W show? And of course that shows an object that's traveling at a constant speed. What about W to X? How does the speed from W to X compare to V to W? Is it faster, slower, or is it moving at the same speed? Have a little think about that. Well, because the line is less steep between W and X, it means W and X is slower than V to W. So from W to X, it is traveling at a constant speed, but it's not traveling as quickly as it was from V to W. What's happening after Z? Have a little look at that, have a think. So the distance isn't changing, therefore the object is stationary. So hopefully you found that useful.